This time we want to learn about connected particle for the object in moving lift. First, let's have a simple diagram for our case study. As we can see, a person is in lift. If we look at it as whole system, we can resolve vertical forces. First, we have total weight, lift, and the person. Besides that, we have tension in cable. If we look further, resolve individually into a person and lift. As for the person, force act on the person are the weight of the person, denoted by WP, and normal reaction from the floor of the lift to the person, denoted by R. As for the lift, force act on the lift are reaction from the person on the floor of the lift, denoted by R, weight of the lift, denoted by WL, and lastly we have tension in cable, denoted by TC. Now, let's see how we can write the mathematical equation of force involved. So now if we resolve as the whole system, what we have there is tension go upward, we have weight of the person go downward, we have weight of the lift go downward. We can write mathematical equation of the force as T minus with weight of the person minus with weight of the lift equal to mass of the person plus with mass of the lift multiplied by acceleration. If we look separately, on the person, force we have is reaction force from the floor to the person and weight of the person. We can write the mathematical equation of the force as reaction force minus with weight of the person equal to mass of the person multiplied with acceleration. And for the lift, we have equation of the force tension minus with weight of the lift minus reaction force equal to mass of the lift multiplied with acceleration. If acceleration value is negative value, there are two possibilities. First, we have the lift traveling upwards but slowing down, or the lift traveling downwards and speeding up. There is two possibilities if the value of acceleration is negative value. Now let's see what happens if acceleration value is positive value. There are two possibilities also. First is the lift may traveling upwards and speeding up, or the lift traveling downwards and slowing down. If the lift is accelerating, normal reaction force from person on the lift is not equal to weight of the person. Now let's see an example for our better understanding. Let's read the question. The diagram shows a lift containing a single passenger. For the question number 1, make a clear diagram to show the forces acting on the passenger and the forces acting on the lift using following letter. So we have here T for the tension in the cable. We have RP for the reaction of the lift on the passenger. We have RL the reaction of the passenger on the lift, we have mg for the weight of the passenger, and we have capital Mg for the weight of the lift. So now let's see how we draw force diagram for both person or passenger and the force for the lift. So we draw a box over there to represent the passenger. So force act on the person over there, we can have weight, which is denoted by mg, and then another force act on the person is reaction of the lift on the passenger, which is denoted by rp. That's only for the force act on the passenger. And for the lift, we draw the bigger box to represent lift. So force act on the lift we have here is weight of the lift itself, denoted by capital mg. We have reaction force from the passenger to on the lift, denoted by rl, and then we have tension in cable go upwards, denoted by T. That's how we draw force diagram for both passenger and lift. So now let's see question number 2. The masses of the lift and the passenger are 450 kg and 50 kg respectively. Question number 2 asks, calculate the value of tension, reaction of the lift on the passenger, and reaction of the passenger on the lift when the lift is stationary. So in order to solve this question, we need to refer back to the force diagram that we have drawn just now. So let's see. So given in the question, the mass of the passenger now is 50 kilograms. So we replace m with 50 and replace capital M with 450 kilogram. So from that value, we can now resolve for the passenger. So for the passenger, we have R of P minus with 50g equal to 0, and then the value of Rp will equal to 50g, or we can write as 500 Newton. Okay, how to find the RL? By using the third law of Newton, we can say that RL will equal to Rp. So the value of RL will equal to Rp, which is equal to 500 Newton also. Next, how to find the tension of the cable? In order to find the tension of the cable, we need to see force act on the lift. So we can write the equation as tension minus with R of L minus with 450 G equal to 0. And then we replace RL with 500 Newton. We will have T minus with 500 minus with 450 G equal to 0. Then the value of the tension of the cable is equal to 500 plus with 450 G, which is equal to 500 plus with 4,500, which is equal to 5,000 Newton. The lift then accelerates upward at 0.8 meter per second square. Find the new values of T, R of P, and R of L. So in order to solve this question, we need to use second Newton's law, which is F equal to ma. So in order to solve the value of T, Rp, and Rl, we need to look at individual force diagram. So first we need to look at passenger. So force act on the passenger, we have Rp minus with 50g equal to mass of the passenger, which is 50, multiplied with acceleration. And acceleration value is already given on the in the question. So we replace what we have there. So we have R of P equal to 500 equal to 50 multiplied with 0.8. So the value of Rp is equal to 50 times with 0.8 plus with 500. So total of it, we will have R of P equal to 540 Newton. And then in order to find the R of L, new R of L, we need to use Newton's third law. R of L will equal to R of P. So we can write over here, R of L equal to 540 Newton also. Alright, so next we want to find the value of tension in the cable. So in order to find the tension in the cable, we need to resolve force act on the lift. So we have there tension minus with R of L minus with 450g equal to mass of the lift, which is we have 550 multiplied with acceleration. So just substitute the value that we have just now. R of L is 540, and then the value of acceleration is 0.8. So the value of T is equal to the value of T minus with 540 Newton minus with 4500 Newton equal to 450 multiplied with 0.8. So the value of T will equal 450 multiplied with 0.8 plus with 540 plus with 4500, which is the value of the tension is equal to 5400 Newton. Let's see another example. A lift and its passenger have a total mass of 400 kg. Find the tension in the cable supporting the lift when first is the lift is at rest. Second, tension of the cable when the lift is moving at constant speed. Third, when the lift is accelerating upward at 0.8 meter per second square. Fourth is when the lift is accelerating downwards at 0.6 meter per second square. First, let's look at the first Roman over there. Before we start, let's draw force diagram on the lift. So we have a box represent lift, and then we have passengers. We just draw one passenger over there, and total mass of the lift and the passenger over there given is 400 kg, and if we convert into weight, we will have 400 g. And then we have cable, and then the tension in cable is denoted by T go upward. If we denote moving upward is positive force, Then for the question A, we can write the equation of force as tension minus with 400 G equal to 0, since the lift is at rest. So the tension of the cable is equal to 400 G, or we can write as 4000 Newton. Alright, for question number 2, Roman, the lift is moving at constant speed. Okay, when the lift is moving at constant speed, we need to know that acceleration is equal to 0. There's no acceleration. So means that the tension minus with 400 G equal to 0, then the tension is also 4000 Newton. Question number 3. The lift is accelerating upward at 0.8 meter per second squared. So we can write the equation now. T minus with 400 G equal to MA, where M is equal to 400 multiplied with acceleration, where the acceleration is, we can replace with 0.8. Since we assume the motion of the lift is go upward as positive, so we just substitute the value of acceleration as positive over here. So the tension is equal to 400 multiplied with 0.8 plus with 4000 Newton. So the tension is equal to 4320 Newton in 3 significant figure. Number 4, the lift is accelerating downward at 0.6 per second square. So mentioned over here, the acceleration is downwards. The direction is go downward, and our early assumption, the motion of the lift is go upward. So in the equation, let's write the equation. We have T minus with 400 G equal to 400 multiplied with acceleration, where the acceleration value over here is equal to negative 0.6. Alright, so the tension is equal to 400 multiplied with negative 0.6 plus with 4000. So the tension is equal to 3760 Newton in 3 significant figure. Here we have a woman of mass 50 kg is traveling in a lift of mass 450 kg. The tension in the cable pulling the lift upwards is 5250 Newton. Calculate the acceleration of the lift. So first, let's draw the force diagram. So we have a box to represent lift, and we have a woman. So total mass of the lift and the woman is equal to 50 plus with 450. And for the weight over there, we just multiply with G. Alright, and then force go upward. Over here, we will have tension. And here, tension is equal to 5250 Newton. And the motion of the lift is go upward. So we take the value of tension as positive value, and the value of the weight, total weight over here, as a negative value. So now let's write into equation of force by using second law of Newton. So now we have 5250 minus with 50 plus 450 times with G equal to 50 plus with 450 multiplied with acceleration. So simplify the equation, we will have 5200 minus with 50 plus 450 multiplied with 10 equal to 5000 equal to 500A. So now we have 250 equal to 500 multiplied with acceleration. So acceleration is equal to 250 divided with 500, which is the value of acceleration is equal to 1/2 meter per second square. Let's see another example. Here we have a man of mass 80 kg and a woman of mass 70 kg are traveling in a lift of mass 500 kg. The tension in the cable pulling the lift upward is 6,890 Newton. Calculate the acceleration of the lift and the reaction forces between the lift floor and each of the passenger. Let's pause the video, have a few minutes to draw diagram force for this problem. Alright, let's check whether you have correct diagram or not. So here we are. So on the lift, we will have go upward force of tension. We have the value of 6,890 Newton. Go downward force, we have weight of the lift itself, we have the value of 5,000 Newton. We have reaction force from the man denoted by R1 and reaction force from the woman denoted by R2. For the man, on the man we have force add on it. We have go upward force R1, which is come from reaction force from the floor of the lift add to the man denoted by R1, and then go downward force of 800 Newton, which is come from weight of the man. For the woman, force add on it is reaction force, second reaction force denoted by R2, which is come from reaction force of the floor to the woman, and then go downward force we have 700 Newton, which is come from weight of the woman itself. In order to solve this equation, we need to resolve individually, or we need to resolve separately. So first we need to resolve force add on the lift. So at lift we have we assume the move upward force is positive force, so we will have 6,890 minus with 5,000 minus with R1 minus with R2 equal to mass of the lift, which is 500 multiplied with acceleration. This is our equation 1. We simplify it, become 1,890 minus with R1 minus with R2 equal to 500A. So let's mark this one as equation 1. And then resolve at a force add on the man, we will have 800 R1 minus with 800 equal to mass of the man is 80 kg multiplied with acceleration. So let's mark this one as our equation 2. And last one, resolve force add on the woman, we have R2 minus with 700 equal to mass of the woman is 70 multiplied with the acceleration. So we have equation 3 here. So in order to solve acceleration and reaction force, we need to solve simultaneous equation we have here. So from equation 2 and equation 3, we have R1 equal to 80A plus with 800, and from equation 3 from equation 3, we have R2 equal to 70A plus with 700. And from both modified equation 2 and equation 3, we sub into equation 1. So what do we have? We can solve for the acceleration. So sub the value of R1 and R2 into equation 1, we will have 1890 minus with 80A plus with 800 minus with 70A plus with 700 equal to 500 multiply with acceleration. Now we have equation of A unknown only. So simplify the equation, we will have 1890 minus with 800 minus with 700 equal to 500A plus with 80A plus with 70A. Solve the equation for A over here. We will have A equal to 0.6 meter per second square. So from the value of A that we have just now, we can find the value of R1 and R2. So R1 equal to 80 multiplied with 0.6 plus with 800. So R1 we will have here is equal to 848 Newton. So this is the value of reaction force from floor on man. And then next we want to find the R2. So value of R2 is equal to 70 multiplied with 0.6 plus with 700. So the value of R2 is equal to 742 Newton. So this is reaction force from floor on woman. Alright, let's see the last example in this video. A passenger lift has mass of 500 kg. The braking tension of the cable is 12,000 Newton. The maximum acceleration of the lift is 0.75 meter per second square. Question A. If the lift travels at its maximum acceleration, calculate the maximum mass of the passengers when first one is the lift is accelerating upwards. Second case is when the lift is accelerating downwards. And for question B, we have taking the average mass of a person to be 75 kg, what is the maximum number of passengers should be allowed to travel in the lift? Alright, let's take a few minutes to draw force diagram for this case. You can pause the video. Alright, here we are. Let's check whether you have correct diagram or not. First, we have upward force as a tension, and given in the equation, maximum tension we have is 12,000 Newton. And then go downward force is weight of the lift itself, which is 5,000 Newton, and we have weight of the passengers, we denote as WP, which is equal to M times with G. And then given also in the equation is maximum acceleration of the lift is equal to 0.75 meter per second square. Here we assume go upward is positive direction. Alright, So in order to find the maximum mass of the passenger for the case of accelerating outward, let's write the equation first. So for question 1 Roman, question A 1 Roman, we have 12,000 minus with 5,000 minus with mg equal to total of mass of the system, which is we have 500 for the mass of the lift plus with m for the mass of passengers, multiply with the acceleration, maximum acceleration, which is we have 0.75. Alright, and then simplify the equation. We will have 7,000 minus with 10m equal to 375 plus with 0.75 m. So solve for the m, we will have m will equal to 616.3 kilogram. So means that 616.3 kilogram is the maximum mass of the passenger when the lift is accelerating upward at maximum value. For question number 2 Roman, we want to find the maximum mass of the passenger when the lift is accelerating downward. So let's resolve for second part of it. So we have 12,000 minus with 5,000 minus with mg, referring to the weight of the passenger, equal to 5,000 weight of 5,000 is mass of the lift plus with the mass of passengers multiply with negative 0.75 for the acceleration. Why we take negative value? Because at the first part we assume move upward or go upward is positive direction. So when we have accelerating downward, the value of acceleration now is equal to negative 0.75. Need to be careful for this value of acceleration. Alright, so solve for the value of m. Simplify the equation first. We will have 7,000 minus with 10m equal to negative 375 minus with 0.75 m. Solve for the value of m. We get the value of m here is equal to 797.3 kilogram. So means that 797.3 kilogram is maximum mass of passenger when the lift accelerating downward with maximum acceleration value. Alright, that is for question number A, first and second Roman. For question number B, taking the average of mass of a person to be 75 kilogram, what is the maximum number of passengers that could be allowed to travel in the lift? Alright, so in order to find the number of passenger, we need to consider minimum mass from the mass we have in equation 1 Roman and second Roman, so that the cable is not breaking. Alright, so from the mass of 616.3 kilogram, we can find the number of passenger, maximum number of passenger here equal to 616.3 divided with 75 kilogram. So we will have the value of 616.3 divided with 75. We had the value of 8.217 number of passenger. But remember, passenger is a people, so we take the integer value, which is we will have number of 8 of passenger. So in order to prevent the cable break, the maximum number of passengers we can have here is equal to 8 people only.